Okay, question 10. A school bus is traveling uphill on a mountainous gravel. As you can see, this school bus is traveling uphill on a mountainous gravel. Due to the bad state of the road, the diesel tank cracked and diesel started leaking quickly. The bus is at a point of A. So as you can see, this is point A, 2 kilometers from the top of the hill, point B. So from this point A up to point B, the distance is 2 kilometers. At the time the tank cracked. So the position rather of the bus with respect to A is given as follows. So this is the position of the bus with respect to A, with respect to this point here, point A, where T is measured in minutes, S is measured in kilometers. 10.1. How far is the bus from point A after just 1 minute? So we know the distance at A of the bus is equals to T minus T squared over 6, right? So we are told that after 1 minute, so we want to know the distance of the bus after 1 minute. So T is equals to 1 minute. So what is the distance? So we're going to substitute that 1. So it's going to be S of T is equals to 1 minus 1 all squared over 6, which is equals to 1 minus 1 over 6, giving us 5 over 6 kilometers. So that is the distance, which approximates to 0.833 kilometers. .2. If the bus reaches the point of the hill at point B, if it reaches this point here, the bus driver will be able to roll free will down the hill to the gauge. So if it happens that this bus reaches this point here, so then it will allow the bus to just roll towards the garage. Since we were speaking that the bus is leaking diesel, right? So will he reach the top of the hill? So that's the question. We want to know if he will be able to reach the top of the hill. If he reaches the top of the hill, then he'll be able to arrive at the garage, because the car will just roll without the use of the diesel, right? So we want to know that will the driver be able to reach point B. So the first thing we're going to do here is we know the equation that defines the position of the bus at A, right? Which is equals to T minus T squared over 6. So this defines the position of the bus at A. So we want to know if it will arrive at B. So how we do that, we need to first find the derivative of this position here, which is going to be 1 minus, we drop the 2 over 6 T2 minus 1. So S derivative is equals to 1 minus, so we divide this out, it's going to be T over 3, right? So now with this here, we know very well that since we derived, we're going to equate S of T being equals to 0. So what we're going to do here, we're going to find time. So 1 minus T over 3, transpose the T over 3 to the other side. So it's T over 3 is equals to 1. Cross multiply, T is equals to 3 minutes. So it's going to take 3 minutes for the bus to move from point A. If you remember, point A is here. We don't know if it's going to arrive at point B, but we know that it's going to move for 3 minutes. So we want to identify now the distance that it's going to move with that 3 minutes. So you're going to substitute the 3 minutes to the original equation. So our t is equals to 3 minutes, but the equation that determines the position of the bus at A is this one, right? So you're going to substitute this 3 minutes, t is equals to 3, to identify the distance that this bus is going to travel. So we're going to say 3 minus into 3 all squared over 6, right? And the distance that I'm getting is 3 over 2 kilometers, which is approximating to 1.5 kilometers. So, but you need to remember that from point A to point B, the distance that was initially given is 2 kilometers, which means it takes 2 kilometers to move from point A to point B. But this bus is going to be able to travel 1.5 kilometers. So this basically tells us that the bus won't be able to reach point B as the diesel leaks too much. So therefore, this means that the bus will only travel 1.5 kilometers and will not be able to reach point B, right? So now we know that the bus won't be able to reach point B. If it doesn't reach point B, which means it won't be able to reach the diesel to fill up the tank. .3. At what speed would the bus be traveling at exactly 1 minute after the diesel tank cracked and started leaking? So we want to know the speed at which this bus is going to travel at, if we know the time is 1 minute. So what we're going to do here is this. We know the distance, the equation that determines the distance of the position of the bus at A is equal to this equation, and we want to identify the speed at which this bus is going to travel at. So this S of t is the distance, right? Or you can call it the displacement. So to find the speed, you have to derive. So when you derive the distance, you get the speed or the velocity. When you derive the velocity, you get acceleration. So we're going to derive this distance here. We're going to have 1 minus 2 over 6 t, which would be 1 minus t over 3. So this equation here defines the velocity of the bus. So we need to substitute t, which we were given t as 1 minute. So s prime of t, which is the same as velocity of t, is equals to 1 minus, instead of writing t, you're going to write 1 minute divided by 3. Therefore, our velocity is 2/3 kilometers per minute. So if you write it in decimal form, it's going to be 0.67 kilometers per minute. So this is going to be the velocity at which this bus travels immediately after 1 minute. So 10.4, calculate the acceleration of the bus at which it is traveling uphill after the diesel has cracked. So we still know that the diesel cracked immediately after 1 minute, right? But in this case, we might not need to know time. So as I said earlier on that if this is a distance of t, and you find the first derivative of t, then you find the second derivative of t. So this is the displacement, right? Displacement, or someone can call it distance. So the derivative of distance gives you velocity. The derivative of velocity gives you acceleration. So to find our acceleration, we're going to say s of t, which is equal to t minus t squared over 6. The derivative, which gives us the velocity, is 1 minus 2 t over 6, which is 1 minus t over 3. And the second derivative of t is equals to 0 minus 1 over 3, which is minus 1 over 3, right? So this is the acceleration. This is the acceleration, s double derivative, which is acceleration, is equals to minus 1 over 3 kilometers per minute squared. So this is the acceleration of the bus. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.